The year was 1934, and the skies above the Soviet Union were about to witness the birth of a revolutionary machine that would reshape aerial warfare forever. In the bustling design bureaus of Moscow, where cigarette smoke mingled with the scent of aviation fuel and the scratch of pencils on blueprints echoed through cramped offices, Andrei Tupolev was crafting something extraordinary. The Tupolev SB, designated ANT-40 in its prototype phase, emerged not just as another warplane, but as a technological leap that would leave the world's aviation experts stunned and scrambling to catch up. Picture the scene at the Central Aerohydrodynamic Institute, where Tupolev's team worked through countless sleepless nights, driven by Stalin's uncompromising demand for a bomber that could outrun any fighter in existence. The Soviet leader's vision was crystal clear: create a flying machine so fast that enemy interceptors would be left eating its exhaust fumes, unable to mount an effective defense. This wasn't merely about building another military aircraft. This was about establishing Soviet technological supremacy in an era when the world was rapidly sliding toward another devastating global conflict. The genesis of the SB lay in the harsh lessons learned from earlier bombing campaigns, where lumbering flying machines had proven nothing more than sitting ducks for agile fighters. Traditional bombers of the early 1930s were essentially flying coffins, their crews resigned to flying straight and level while enemy fighters picked them apart with methodical, deadly precision. Tupolev understood with brilliant clarity that speed would become the new armor, and his dedicated team set about creating a warplane that would revolutionize the very concept of strategic bombing operations. What emerged from those Moscow drawing boards was nothing short of breathtaking. The SB boasted clean, aerodynamic lines that seemed to slice through the air even while stationary on the tarmac. Its sleek fuselage, completely devoid of the drag-inducing struts and wire bracing that plagued earlier designs, spoke eloquently of a new era in aviation engineering. The flying machine's distinctive nose, housing a bombardier's position with exceptional visibility, gave it an almost predatory appearance, while its twin-engine configuration promised the raw power needed to fulfill its ambitious performance requirements. The power plant selection proved absolutely crucial to the SB's eventual success. Initially fitted with French Hispano-Suiza 12Y engines producing 860 horsepower each, the bomber could achieve speeds that left contemporary fighters struggling desperately to intercept. Later variants would receive even more powerful Soviet-built Klimov M103 engines, pushing performance to levels that seemed almost magical to those witnessing early test flights. Pilots who first encountered the SB in combat operations often reported complete disbelief at its acceleration and top speed, describing in vivid detail how the sleek bomber would simply disappear over the horizon before defensive measures could be properly organized. The development process itself reads like an intricate thriller novel, filled with political intrigue, monumental technical challenges, and the ever-present pressure of Stalin's sky-high expectations. Fearless test pilots pushed experimental prototypes to their absolute limits, exploring flight envelopes that had never been attempted by bombers before in aviation history. Extensive wind tunnel tests revealed aerodynamic properties that exceeded even Tupolev's most optimistic projections, while rigorous stress testing proved beyond doubt the airframe's remarkable ability to withstand the tremendous forces generated by high-speed flight and violent combat maneuvering. Stalin himself took a personal interest in the project, regularly demanding progress reports and occasionally visiting the design bureau to examine blueprints and question engineers about technical details. The Soviet leader understood instinctively that air power would prove decisive in future conflicts, and he was determined that his nation would possess the most advanced bombers in the world. His backing provided Tupolev with virtually unlimited resources and the highest priority for materials and skilled workers, but it also brought enormous pressure to deliver results quickly. The political climate of the mid-1930s added another layer of complexity to the development process. Purges were sweeping through Soviet society, and aviation designers knew that failure could result in far more than professional disappointment. Success meant recognition, resources, and continued freedom to innovate. Failure could mean disgrace, imprisonment, or worse. This atmosphere of fear and opportunity pushed Tupolev's team to extraordinary efforts, working around the clock to solve technical problems that had never been encountered before. Early prototype testing revealed capabilities that seemed almost impossible to contemporary aviation experts. During one memorable demonstration flight, an SB prototype easily outran a pursuing fighter, climbing steadily while maintaining a speed that left the interceptor far behind. Word of such performances spread rapidly through international aviation circles, creating both admiration and deep concern among foreign military observers who realized that aerial warfare was about to change dramatically. The aircraft's innovative features extended far beyond raw performance. The SB incorporated retractable landing gear at a time when most bombers still relied on fixed undercarriages that created significant drag. Its internal bomb bay was fully enclosed within the fuselage, eliminating the aerodynamic penalties of external ordnance mounting. Even seemingly minor details like flush-mounted rivets and carefully faired surface joints demonstrated an obsessive attention to drag reduction that placed Soviet aviation technology years ahead of international competitors. As word of the SB's remarkable capabilities began to leak beyond Soviet borders, intelligence agencies across Europe scrambled desperately to gather information about this mysterious new warplane. Foreign military attaches in Moscow filed increasingly urgent reports describing tantalizing glimpses of a bomber that seemed to defy conventional aviation wisdom. Diplomatic receptions and trade missions became cover for intelligence-gathering operations as Western powers struggled to understand how the Soviets had achieved such a dramatic technological breakthrough. The mere existence of such an advanced machine sent genuine shockwaves through military planning departments from London to Tokyo, forcing a complete reevaluation of existing air defense strategies and fighter development programs. Traditional interceptor tactics, based on the assumption that bombers would be slow and predictable targets, suddenly seemed obsolete. Anti-aircraft gun positions, designed to engage lumbering targets at moderate altitudes, would need complete redesign to deal with high-speed, high-altitude threats. British intelligence reports from this period, declassified decades later, reveal the depth of concern among Western military planners. Air Ministry officials worried privately that the Royal Air Force's newest fighters might prove inadequate against Soviet bombers capable of such extraordinary performance. Similar concerns echoed through the corridors of the Pentagon and the Japanese War Ministry, where planners struggled to comprehend the implications of high-speed bombing operations. The rollout of the first production SB in early 1936 marked a truly pivotal moment in aviation history. As the gleaming machine emerged from the factory floor, its polished aluminum skin reflecting the harsh Moscow sunlight, observers knew instinctively they were witnessing something unprecedented in military aviation. The bomber's elegant proportions and unmistakably purposeful stance conveyed power and speed in equal measure, while its advanced features hinted at the technological sophistication hidden beneath its deceptively simple exterior. This was no mere evolutionary step in bomber development. This was a revolutionary leap that would reshape aerial warfare for decades to come. The SB represented the culmination of years of intensive research, innovative engineering, and relentless pursuit of aerodynamic perfection. More than just an aircraft, it embodied Stalin's vision of Soviet technological superiority and served notice to the world that the Soviet Union had emerged as a major power in military aviation development. Factory workers who had labored to build this remarkable machine understood that they were creating something special. Many had worked on earlier bombers that seemed crude by comparison, and they could see in the SB's sleek lines and sophisticated systems a quantum leap in aviation technology. The pride they felt in their craftsmanship would soon be validated by combat performance that exceeded even the most optimistic expectations of its designers. The thunderous roar of twin Hispano-Suiza engines echoed across the vast expanses of the Soviet Union as the Tupolev SB entered full-scale production in 1936, marking the dawn of a new era in military aviation. Factory workers in manufacturing plants from Moscow to Kazan labored around the clock, their hammers and riveting guns creating a symphony of industrial might as they assembled what would become one of history's most influential bomber designs. Each gleaming machine that rolled off the production line represented not just Soviet engineering prowess, but a fundamental shift in the balance of aerial warfare that would echo through the corridors of military headquarters worldwide. The SB's technical specifications read like a wish list that had somehow materialized into polished aluminum reality. With a maximum speed approaching 280 miles per hour at altitude, this sleek warplane could genuinely outrun most contemporary fighters, transforming the traditional bomber versus fighter equation into something entirely new and terrifying for enemy air defense planners. Its service ceiling of over 31,000 feet placed it comfortably above the effective range of most anti-aircraft guns of the era, while its operational range of nearly 1,000 miles gave Soviet commanders unprecedented strategic reach across European and Asian battlefields. The flying machine's spacious internal bomb bay could accommodate up to 1,500 pounds of ordnance, delivered with pinpoint precision that made previous bombing attempts look like crude approximations hurled from medieval catapults. The cockpit environment of an SB told an intricate story of Soviet attention to both functionality and crew survival under the most demanding combat conditions imaginable. The pilot's position offered exceptional visibility through large, strategically positioned windows that provided crucial situational awareness during high-speed combat maneuvers and formation flying. The comprehensive instrument panel displayed flight data that professional aviators could only dream of in earlier machines: precise altitude indicators, reliable airspeed measurements, detailed engine performance monitors, and sophisticated navigation aids that transformed flying from an artistic endeavor into an exact science. Radio equipment, remarkably sophisticated for its time, enabled seamless coordination between multiple bombers in tight formations and maintained vital communication links with ground controllers directing increasingly complex missions across vast distances. The electrical systems powering these advanced components represented cutting-edge technology, incorporating redundant circuits and backup power sources that ensured continued operation even when primary systems suffered battle damage or mechanical failure during extended combat operations. The bombardier station, housed within the warplane's distinctive glazed nose section, provided an unobstructed panoramic view of target areas far below. This crucial position, equipped with precision optical bomb sights that rivaled the best Western designs, transformed strategic bombing from hopeful approximation into surgical strike capability that could place ordnance within yards of intended targets. The bombardier's carefully designed workspace included detailed topographical maps, complex targeting calculations, and sophisticated release mechanisms that could deliver multiple bomb types with accuracy that seemed almost supernatural to ground observers watching from safe distances. Temperature controls and oxygen systems throughout the crew compartments ensured that all personnel could function effectively even during extended high-altitude missions over heavily defended enemy territory. These life support systems, often overlooked by casual observers, proved absolutely crucial during combat operations where crews might spend hours at altitudes that would quickly prove fatal without proper environmental protection. Meanwhile, the dorsal gunner's position, though admittedly cramped by the standards of larger strategic bombers, offered reasonable protection and excellent fields of fire for the defensive machine guns that would prove absolutely crucial in combat situations. The precisely engineered gun mount could traverse rapidly and smoothly to engage fast-moving threats approaching from multiple directions, while the sophisticated ammunition storage system, carefully designed to prevent jamming during violent combat maneuvers, ensured sustained defensive fire when bomber formations found themselves under determined and prolonged fighter attack. Perhaps most remarkably for an aircraft of its era, the SB incorporated numerous advanced design features that wouldn't become common in other air forces for several more years, demonstrating Soviet willingness to embrace radical innovations that more conservative aviation establishments dismissed as unnecessarily complicated or unreliable. Retractable landing gear, an extreme rarity in 1936 when most flying machines still relied on fixed undercarriages that created enormous drag penalties, reduced air resistance significantly and contributed directly to the bomber's impressive performance figures that left international observers genuinely speechless. The complex hydraulic systems required for reliable gear operation represented absolute cutting-edge technology that pushed Soviet manufacturing capabilities to their limits and beyond. Engineers solved numerous technical challenges related to hydraulic fluid performance in extreme temperatures, seal reliability under varying pressure conditions, and mechanical backup systems that could extend the landing gear manually if primary systems failed during critical landing approaches. The internal bomb bay, fully enclosed within the fuselage and aerodynamically seamless when closed, eliminated the substantial drag penalties associated with external ordnance mounting that plagued virtually all contemporary bomber designs. This seemingly simple innovation required sophisticated structural engineering to maintain essential fuselage strength while creating the necessary internal volume for bomb storage and release mechanisms. Load distribution systems ensured that asymmetric bomb loading wouldn't create dangerous flight characteristics, while specialized heating systems prevented ordnance from freezing during high-altitude operations in severe winter conditions. Even seemingly minor details like flush-mounted rivets and carefully faired surface joints demonstrated an obsessive level of aerodynamic sophistication that placed Soviet aviation technology at the absolute cutting edge of global development, surpassing even the most advanced Western designs in several crucial areas. Wind tunnel testing had revealed that such attention to surface smoothness could improve overall performance by several percentage points, translating into valuable increases in speed, range, and operational ceiling. The manufacturing process itself represented nothing short of a triumph of Soviet industrial organization and technological determination on an unprecedented scale. Factories that had been producing agricultural tractors and farming equipment just years earlier were completely retooled with remarkable efficiency to create precision flying machine components, their workers receiving intensive training in manufacturing techniques that pushed the boundaries of 1930s industrial technology far beyond what had been thought possible. This massive industrial transformation required not just new machinery and specialized tools, but fundamental changes in quality control procedures, comprehensive worker training programs, and sophisticated supply chain management systems that touched every aspect of Soviet industrial capability. Raw materials had to meet exacting specifications never before required in Soviet manufacturing, while precision tolerances demanded machining accuracy that challenged existing capabilities. Quality control procedures, implemented under the watchful supervision of state inspectors who understood perfectly that bomber performance could mean the difference between glorious victory and catastrophic national defeat, ensured that each individual SB met exacting standards for both performance and long-term reliability that exceeded anything previously achieved in Soviet aviation production. These inspectors possessed absolute authority to reject any component or assembly that failed to meet specifications, regardless of production pressure or delivery schedules. Workers throughout the manufacturing process understood instinctively that the warplanes they were building with such care and precision would soon carry their own sons and brothers into deadly combat against determined enemies. This knowledge created an unprecedented level of personal investment in manufacturing quality that showed clearly in every carefully installed component, every perfectly aligned control surface, and every meticulously tested system throughout each completed aircraft. Training programs for SB crews became legendary within Soviet aviation circles, establishing entirely new standards for aircrew preparation that would eventually influence military aviation training programs worldwide. Pilots selected for assignment to the revolutionary new bomber underwent many months of intensive instruction covering not just fundamental flying techniques, but advanced high-speed navigation procedures, precision formation flying at unprecedented velocities, and sophisticated bombing techniques from altitudes that previous generations of military airmen had considered virtually impossible to reach reliably with existing aircraft and equipment. The bomber's advanced systems demanded a completely new breed of military aviator, one thoroughly comfortable with technology that seemed almost futuristic compared to the fabric-covered, wire-braced contraptions that had dominated earlier aerial conflicts. These carefully selected men needed to master complex engine management procedures that optimized performance under varying conditions, sophisticated navigation techniques that enabled precise course-keeping across vast distances, and intricate coordination skills that transformed individual bomber crews from collections of separate specialists into precision military instruments capable of executing the most demanding missions with clockwork efficiency. As production steadily ramped up throughout 1936 and 1937, the distinctive silhouette of the SB began appearing regularly at military air bases across the immense expanse of the Soviet Union, from the windswept Baltic coast to the remote Pacific shores. Each new delivery brought with it a genuinely palpable sense of technological pride and rapidly growing military confidence that permeated every level of the Soviet Air Force command structure, from squadron leaders to the highest levels of military planning. The Spanish Civil War erupted in July 1936, and within months, this brutal conflict transformed into a testing ground for military technologies that would ultimately shape the coming World War. Into this cauldron of ideological hatred and technological experimentation, the Soviet Union quietly introduced its revolutionary new bomber, the Tupolev SB. Operating under the affectionate designation Katiuska by Republican forces, these sleek machines would write their names indelibly in aviation history with missions that completely redefined what bombers could achieve in modern combat operations. The first SB units arrived in Spain aboard Soviet merchant vessels, their precious flying machines carefully crated and accompanied by volunteer crews who spoke fluent Spanish but possessed unmistakably Slavic features and accents. These men, officially described as civilian contractors but actually experienced Soviet Air Force personnel, brought with them not just technologically advanced warplanes but revolutionary tactical doctrines that would fundamentally transform Republican air operations. The sight of these gleaming bombers being methodically assembled at Republican airfields sent visible ripples of excitement through anti-fascist forces while simultaneously creating corresponding waves of deep concern through opposing nationalist camps. Combat debut came with startling swiftness, and the results exceeded even the most optimistic Soviet projections by considerable margins. SB formations, flying at speeds that left enemy fighters struggling desperately to intercept, struck targets across nationalist-held territory with devastating effectiveness that shocked military observers on both sides. The bombers' remarkable ability to outrun determined pursuit became instantly legendary among Republican crews, who spoke with evident pride and amazement about missions where enemy fighters simply couldn't catch them despite their best efforts. One Soviet pilot, writing in a letter home that somehow survived the war's destruction, described watching enemy aircraft falling steadily behind until they appeared as distant specks against the Spanish sky, their frustrated pilots undoubtedly cursing the severe limitations of their slower warplanes. Such experiences became routine for SB crews, fundamentally altering their psychological approach to combat operations and creating a confidence that proved infectious throughout Republican aviation units. The psychological impact of the SB's extraordinary performance proved every bit as significant as its physical destruction of military targets. Nationalist forces, thoroughly accustomed to dealing with slower, more vulnerable bombers using established defensive tactics, found their existing air defense procedures suddenly rendered completely obsolete. Anti-aircraft gun crews struggled desperately to track targets moving at previously unimaginable speeds, while fighter pilots discovered with growing frustration that traditional interception techniques simply didn't work against flying machines capable of accelerating away from trouble faster than pursuit formations could be properly organized. Perhaps most remarkably for military aviation history, the SB's outstanding combat record in Spain demonstrated conclusively that speed truly had become the new armor in aerial warfare. Loss rates for SB units remained remarkably low compared to other bombers operating extensively in the conflict, thoroughly validating Tupolev's fundamental design philosophy and operational concepts. When losses did occasionally occur, they typically resulted from concentrated ground fire during dangerous low-level attacks or mechanical failures rather than successful fighter interceptions, proving the effectiveness of the high-speed bombing concept. The missions themselves quickly became the stuff of aviation legend. SB formations would appear over designated targets with minimal advance warning, deliver their deadly ordnance with precision that absolutely astounded ground observers, and disappear completely before effective countermeasures could be mounted by defensive forces. Strategic bridges, military airfields, crucial supply depots, and concentrated troop formations fell victim to attacks that seemed to materialize from thin air before vanishing just as mysteriously. The bomber's distinctive glazed nose section, housing its skilled bombardier and sophisticated optical aiming equipment, proved devastatingly effective at placing explosive ordnance exactly where Republican commanders wanted maximum destruction. The accuracy achieved by experienced SB crews often exceeded that of artillery pieces firing from much shorter ranges, demonstrating the revolutionary potential of precision high-speed bombing operations. Enemy pilots who occasionally managed to engage SBs in direct combat reported experiences that bordered on the completely surreal. Traditional fighter tactics, based firmly on the logical assumption that bombers would maintain steady course and speed to facilitate successful interception, simply didn't apply to warplanes capable of violent evasive maneuvers at speeds approaching those of the interceptors themselves. More than one enemy pilot reported the profoundly humbling experience of being systematically outrun by a fully loaded bomber, a psychological blow that shattered long-held preconceived notions about the fundamental nature of aerial warfare. The Spanish experience also revealed the SB's truly remarkable operational versatility in ways that surprised even its designers. While originally conceived and designed primarily as a medium-range strategic bomber, the flying machine proved equally effective in demanding reconnaissance roles, its exceptional speed and altitude capabilities making it virtually impossible to intercept during crucial intelligence-gathering missions deep behind enemy lines. Photo reconnaissance versions, specially equipped with high-quality cameras in place of bomb loads, brought back detailed intelligence information that proved absolutely crucial to Republican military planning and strategic decision-making. The warplane's impressive operational range enabled deep penetration missions that provided comprehensive information about enemy positions, troop concentrations, and strategic intentions that would have been impossible to obtain through conventional ground-based intelligence networks. These reconnaissance flights often covered hundreds of miles of hostile territory, photographing military installations, supply routes, and defensive positions with impunity. Ground crews, both experienced Soviet technicians and hastily trained Spanish mechanics, quickly learned to appreciate the SB's outstanding reliability and relative ease of maintenance under field conditions. Unlike more complex machines that required extensive ground support infrastructure and specialized facilities, the bomber could operate effectively from relatively primitive airfields with minimal maintenance facilities and equipment. Its rugged construction philosophy absorbed the inevitable wear and tear of intensive combat operations while consistently maintaining the exceptional performance characteristics that made it so formidable against enemy forces. Experienced mechanics spoke with genuine admiration about engines that continued running smoothly despite irregular maintenance schedules imposed by combat conditions, and airframes that tolerated rough handling and less-than-perfect landing strips without losing structural integrity or flight performance. This reliability proved crucial in the chaotic conditions of civil war, where supply lines were uncertain and maintenance facilities often came under enemy attack. As the Spanish conflict gradually progressed through 1937 and beyond, enemy forces slowly developed increasingly sophisticated countermeasures specifically designed to deal with the persistent SB threat. Newer, significantly faster fighters began appearing in nationalist inventories through assistance from friendly nations, while anti-aircraft tactics evolved considerably to account for high-speed, high-altitude targets that had never been encountered before. However, even these determined adaptations could only partially offset the truly revolutionary capabilities that the SB brought to Spanish battlefields. The fundamental advantage of speed over conventional interception methods remained decisive throughout the entire conflict, proving repeatedly the validity of Tupolev's original vision and design philosophy. The lessons learned in Spanish skies would prove absolutely invaluable when much larger conflicts erupted across Europe and Asia, with SB crews returning to the Soviet Union carrying combat experience that no other air force in the world possessed. Their detailed reports, filled with technical observations and hard-won tactical insights, would profoundly influence Soviet bomber development and operational doctrine for many years to come, helping to prepare the Red Air Force for the even greater challenges that lay ahead. By 1939, the storm clouds of global conflict were gathering with increasingly ominous intensity, and the Soviet Union found itself facing serious military threats on multiple widely separated fronts. The Tupolev SB, now a thoroughly proven combat veteran from its Spanish trials, would soon face its most demanding tests in the brutal conflicts that erupted along Soviet borders. From the bone-chilling battlefields of the Winter War against Finland to the scorching steppes of Kokon Gol, where Soviet and Japanese forces clashed in undeclared but savage warfare, the sleek bomber would once again demonstrate its exceptional worth under the most challenging operational conditions imaginable. The Winter War of 1939 to 1940 presented absolutely unique challenges that tested every single aspect of the SB's carefully engineered design philosophy. Finnish winters, with their bone-numbing cold and wildly unpredictable weather patterns, pushed both sophisticated flying machines and their human crews to their absolute operational limits. SB formations, operating from heavily fortified bases deep within Soviet territory, flew extremely long-range missions over landscapes completely transformed into frozen wastelands, where familiar navigation landmarks disappeared entirely beneath thick blankets of snow and treacherous ice formations. The warplane's remarkably reliable engines and robust construction proved absolutely crucial in environmental conditions that routinely grounded lesser aircraft and left them helplessly stranded. Engine oil that would freeze solid in other machines continued flowing smoothly in SB power plants, while electrical systems maintained consistent operation despite temperatures that challenged the very limits of human endurance and equipment reliability. Finnish air defenses, though admittedly limited in overall scope and numbers, demonstrated remarkable ingenuity and tactical flexibility in dealing with high-speed bomber attacks that had never been encountered before. Anti-aircraft batteries, strategically positioned around key military and civilian targets, developed rapid-fire techniques specifically designed to saturate likely flight paths with concentrated defensive fire. Finnish fighter pilots, flying individually superior aircraft and possessed of exceptional flying skills, proved conclusively that experienced aviators in capable warplanes could occasionally intercept even the swift SB formations when tactical conditions favored the defenders. However, the bomber's fundamental speed advantage continued providing a crucial margin of safety for the vast majority of combat missions, enabling formations to escape pursuit even when caught in disadvantageous positions. The psychological warfare aspect of SB operations proved particularly effective during the Winter War's brutal campaigns. The distinctive, unmistakable sound of twin engines approaching at high speed became a dreaded harbinger of destruction for Finnish defenders, who learned to recognize approaching bomber formations by their characteristic engine notes long before visual contact became possible through the Arctic haze. This auditory warning system, while providing some precious preparation time for defensive measures, simultaneously created a profound sense of helplessness among ground forces who understood perfectly that their positions were about to be struck with devastating precision regardless of their preparations. Combat missions during this harsh period showcased the SB's truly remarkable adaptability to extreme environmental conditions that would have defeated less robust designs. Specialized bomb bay heaters, absolutely essential for preventing ordnance from freezing solid during extended high-altitude flight operations, worked flawlessly even in temperatures that challenged human survival limits. Sophisticated navigation equipment, crucial for finding small targets in the virtually featureless white landscape stretching endlessly below, proved consistently reliable despite conditions that regularly disabled less advanced systems. Simultaneously, thousands of miles to the east along the remote Mongolian border, SB units were writing another dramatic chapter in combat aviation history during the intense Kokon Gol conflict. Here, in battles that would serve as an invaluable dress rehearsal for the much larger conflicts soon to come, Soviet bombers faced the formidable Japanese Army Air Force in sustained combat that demonstrated the rapidly evolving nature of modern aerial warfare. The vast distances and extremely harsh terrain of Central Asia provided a completely different but equally challenging operational environment for bomber crews accustomed to European conditions. Japanese fighters, widely recognized among the most technically advanced in the world at that time, provided SB crews with their most serious aerial opposition since the Spanish Civil War campaigns. Warplanes like the highly maneuverable Nakajima Ki-27, flown by exceptionally experienced and aggressive pilots, could pose genuine mortal threats to bomber formations that became separated from mutual support or were caught at tactically disadvantageous altitudes. However, the SB's proven speed advantage continued providing crucial survivability margins. consistently allowing formations to outrun determined pursuit when tactical situations became untenable or overwhelming. The punishing desert conditions at Kok and GOL tested entirely different aspects of SB reliability and operational endurance. Sand and dust, omnipresent in the harsh Central Asian environment, challenged engine air filtration systems and demanded constant, meticulous maintenance attention from overworked ground crews. Radio equipment, absolutely crucial for coordinating multiple bomber formations across vast operational distances, had to maintain reliable operation despite severe atmospheric interference that played havoc with communication systems. The flying machine's fundamentally robust construction and consistently reliable mechanical systems proved more than equal to these environmental challenges, maintaining essential operational readiness despite conditions that would have completely sidelined more delicate or complex designs. Target acquisition in the sprawling, fluid battlefield of Kok and GOL proved particularly challenging for bombardiers accustomed to attacking fixed installations. Unlike the clearly defined urban and industrial objectives typical of European warfare, the highly mobile nature of mechanized combat across seemingly endless steppes required bomber crews to identify and engage targets that were often small, expertly camouflaged, and constantly moving. The SB's distinctive glazed nose section, providing exceptional visibility for skilled bombardiers, proved crucial in these demanding operations. Sophisticated optical bomb sights, coupled with the aircraft's inherently stable bombing platform characteristics, enabled precision attacks on targets that would have been virtually impossible to engage effectively with less advanced equipment. The collaborative nature of operations during these remote border conflicts highlighted the SB's excellent integration within larger, more complex military structures. Close cooperation with rapidly advancing ground forces required absolutely precise timing and exceptional navigational accuracy, capabilities that the bomber's advanced systems provided consistently and reliably. Radio communications between aircraft formations and ground controllers became increasingly sophisticated throughout these campaigns, enabling real-time target adjustments and immediate damage assessments that dramatically maximize the effectiveness of each dangerous mission. Perhaps most significantly for future operations, these challenging conflicts provided absolutely invaluable combat experience for the massive numbers of aircrew who would soon face the ultimate test of the Great Patriotic War. Pilots, bombardiers, and gunners who survived both the Finnish and Japanese conflicts returned to their home units carrying hard-won knowledge about high-speed bomber tactics, enemy capabilities, and the crucial importance of seamless coordination between different military branches and services. The dawn of June 22, 1941, brought with it the thunderous sound of thousands of aircraft engines as the largest military operation in human history began to unfold across the western borders of the Soviet Union. Operation Barbarossa, the massive three-pronged assault that hurled over 3 million Axis troops against Stalin's forces, would test every piece of military equipment in the Soviet arsenal to its absolute breaking point. Among the warplanes that would face this unprecedented challenge, the battle-tested Tupolev SB stood as both a symbol of pre-war Soviet technological achievement and a crucial component in the desperate defense of the homeland. The initial hours of Barbarossa proved absolutely catastrophic for Soviet aviation forces. Military airfields across the western regions erupted in towering flames as enemy bombers struck with devastating precision, destroying hundreds of precious flying machines on the ground before their crews could even reach their aircraft through the chaos. However, those SB units that managed to escape the initial onslaught quickly demonstrated why this remarkable bomber had earned its fearsome reputation as one of the world's premier combat warplanes during its Spanish and border war campaigns. Speed, the SB's greatest operational asset, suddenly became a matter of life and death as surviving formations raced desperately to strike advancing enemy columns before they could penetrate deeper into Soviet territory. The bomber's proven ability to outrun pursuit proved invaluable during these dark early days when Soviet fighters were overwhelmed by superior enemy numbers and often unavailable to provide protective escort coverage. The utterly chaotic nature of the early campaign created unprecedented opportunities for SB crews to demonstrate their aircraft's remarkable capabilities under the most extreme operational conditions imaginable. Missions that would have been considered impossible during peacetime training exercises became routine operational necessities. Bombers operating from hastily prepared emergency airstrips, sometimes nothing more than roughly cleared agricultural fields, struck targets identified only hours or even minutes before takeoff through desperate intelligence reports. Navigation equipment that had seemed sophisticated during peacetime training exercises proved absolutely invaluable when familiar landmarks disappeared entirely beneath the thick smoke of burning cities and devastated villages. Radio communications, often disrupted by enemy jamming and atmospheric interference, required crews to rely heavily on visual navigation and dead reckoning techniques perfected during their extensive pre-war training programs. Enemy fighter opposition, initially overwhelming in both sheer quantity and individual aircraft quality, gradually encountered the SB's fundamental operational advantages that had been proven in earlier conflicts. While individual enemy warplanes might possess superior performance characteristics in specific flight regimes, the bomber's exceptional speed and altitude capabilities continued providing crucial survivability margins that meant the difference between mission success and catastrophic loss. Formation flying techniques, originally perfected during the Spanish conflict and systematically refined through subsequent border wars, enabled SB units to concentrate their defensive firepower while simultaneously maintaining the critical speed advantages that made successful interception extremely difficult for enemy fighters. These tactical formations became increasingly sophisticated as crews gained combat experience, with lead bombers providing navigation and target identification while trailing aircraft maintained optimal positions for mutual defensive support. The profound psychological impact of SB operations during this desperate period simply cannot be overstated in terms of Soviet morale and military effectiveness. Soviet ground forces, reeling from the initial Axis assault and struggling desperately to establish coherent defensive positions, drew enormous encouragement from the inspiring sight of their own bombers striking back courageously at the seemingly unstoppable advancing enemy formations. The distinctive silhouette of SB formations, flying at altitudes that placed them safely beyond the effective range of most small arms fire, became a powerful symbol of continued Soviet resistance and ultimate victory despite the apparent hopelessness of the immediate tactical situation. These visible demonstrations of continued Soviet air power provided crucial psychological support to retreating ground forces who might otherwise have lost all hope of eventual victory. Target selection during the chaotic early months of the war required unprecedented operational flexibility and lightning-fast decision-making capabilities from mission planners and aircrew alike. Bridge demolition missions, carefully designed to slow enemy advances by destroying crucial river crossings, demanded precision bombing that pushed existing bombsight technology to its absolute limits while operating under intense time pressure. Supply column attacks required split-second timing and perfect coordination between multiple aircraft operating in extremely dangerous low-level flight profiles. Airfield strikes, intended to disrupt increasingly sophisticated enemy air operations, needed to be executed despite rapidly improving enemy air defenses and the constant threat of fighter interception during the most vulnerable approach and attack phases. The warplane's defensive armament, frequently criticized as inadequate during peacetime evaluations by armchair military theorists, proved surprisingly effective under actual combat conditions where human factors often outweighed pure technical specifications. Dorsal and ventral gun positions, expertly manned by experienced gunners who had learned their deadly craft during Spanish and border war campaigns, could generate sufficient concentrated firepower to discourage all but the most determined and skillful interceptors. The crucial psychological effect of accurate return fire, even when actual physical damage to attacking fighters remained limited, often proved sufficient to disrupt enemy attack formations and provide bomber formations with the precious seconds needed to escape to safety. This defensive capability, combined with the SB's fundamental speed advantages, created a synergistic effect that made the bomber far more survivable than pure performance specifications might suggest. Maintenance operations under wartime conditions tested every aspect of the SB's fundamental design philosophy and engineering excellence. Flying machines that had been meticulously maintained by highly trained specialist technicians in well-equipped peacetime facilities now had to remain operationally ready despite primitive field conditions, irregular supply schedules, and the constant threat of enemy attack on maintenance areas. The bomber's inherently robust construction and consistently reliable power plants proved absolutely crucial during this difficult transition from peacetime luxury to wartime necessity. Engines continued operating smoothly despite extended periods between major overhauls, while airframe structures absorbed combat damage and rough field operations without losing essential flight characteristics or structural integrity. As the initial enemy advance finally slowed during the brutal winter of 1941 to 1942, SB units had compiled one of the most remarkable records in military aviation history. Despite facing overwhelming odds and operating under conditions that would have been considered absolutely impossible during peacetime planning, these aircraft and their incredibly brave crews had demonstrated conclusively that technological excellence, when combined with exceptional courage and unwavering determination, could make a decisive difference even during the darkest hours of national survival and existential threat. The turning of the tide in the Great Patriotic War brought with it fundamentally new roles and unprecedented challenges for the veteran Tupolev SB. As Soviet forces began their long, bloody advance westward from the gates of Moscow, the warplane that had served as a defensive bulwark during the darkest days of 1941 gradually transformed into a powerful instrument of liberation and ultimate victory. The bomber's thoroughly proven capabilities, refined through years of intensive combat experience, made it an invaluable strategic asset in operations that would carry the Red Banner across a devastated continent. By 1943, the operational nature of SB missions had evolved considerably from the desperate improvisations of the early war period. Soviet industry, now producing aircraft and weapons at absolutely unprecedented rates from relocated factories beyond enemy reach, provided bomber units with significantly improved equipment and much more regular supply schedules. However, the fundamental characteristics that had made the SB effective during the desperate defensive phase, exceptional speed, proven reliability, and surgical precision proved equally valuable during massive offensive operations against increasingly sophisticated enemy defenses. The prolonged siege of Leningrad provided perhaps the most dramatic example of the SB's remarkable evolution during the latter stages of the war. Dangerous supply missions, flying over the frozen expanse of Lake Ladoga and through intense anti-aircraft fire, demonstrated the warplane's extraordinary ability to operate under conditions that pushed both sophisticated machines and their human crews to their absolute operational limits. Navigation in complete darkness, through weather conditions that routinely grounded lesser flying machines, became almost routine for experienced crews who had learned their deadly trade during the desperate early years of the conflict. These missions required not just exceptional flying skills, but incredible courage and determination from aircrew who understood that civilian survival in the besieged city depended entirely on their success. Air superiority, gradually achieved through the massive expansion of Soviet fighter production and improved pilot training programs, allowed SB formations to operate with increasing freedom over enemy-held territory. The psychological tables had completely turned. Where once Soviet bombers had been the hunted prey, enemy ground forces now listened with growing dread to the approaching sound of twin engines that invariably heralded destruction from above. The bomber's distinctive engine note, once a cherished source of pride for Soviet listeners, became an ominous harbinger of doom for enemy positions throughout occupied Europe. This psychological reversal represented far more than simple tactical advantage. It symbolized the fundamental shift in military momentum that would ultimately determine the war's outcome. The systematic liberation of Soviet territory revealed the full horrific extent of enemy occupation policies, providing SB crews with additional powerful motivation for their increasingly dangerous missions. Aircrew who flew reconnaissance flights over destroyed cities and systematically devastated countryside brought back detailed reports that stiffened resolve throughout the entire Soviet military structure. The bomber, originally conceived as a purely military instrument for strategic operations, had evolved into something far more significant, a weapon of liberation carrying both high explosives and renewed hope to populations that had endured years of brutal foreign occupation. This transformation from military tool to symbol of national resurgence would profoundly influence how the aircraft was remembered in post-war Soviet military culture. Technical modifications, systematically implemented based on hard-won combat experience, continuously improved the SB's effectiveness in its constantly evolving operational roles. Enhanced defensive armament, including improved gun mounts and substantially increased ammunition capacity, reflected crucial lessons learned from countless deadly encounters with enemy fighters throughout various theaters of operation. Navigation equipment upgrades enabled precision attacks during the extended hours of northern winter darkness, while sophisticated communication improvements allowed much better coordination with rapidly advancing ground forces and other warplanes operating in increasingly complex battlespace environments. These incremental improvements, while individually modest, collectively transformed the SB into a far more capable weapon system than its original designers had ever envisioned. As victory finally approached and enemy resistance began collapsing across multiple fronts, SB formations participated directly in the final strikes that brought the European conflict to its dramatic conclusion. Aircraft that had defended Moscow during its darkest hour now flew over Berlin as conquering eagles, their battle-hardened crews serving as witnesses to one of history's most dramatic reversals of military fortune. The bomber that had been born from Stalin's ambitious vision of Soviet technological supremacy had ultimately fulfilled its destiny, carrying the red banner of victory across an entire continent and securing its place in military aviation history forever. Production of the SB officially ended in 1941, but not before over 6,600 examples had rolled off Soviet production lines, making it one of the most numerous bombers of its historical era. Export versions, delivered to Allied nations throughout the turbulent 1930s and early 1940s, served with distinction in air forces from China to Czechoslovakia, carrying Soviet design philosophy and proven tactical doctrines to military organizations around the globe. These international operators provided valuable feedback about the warplane's performance under widely different operational conditions, contributing significantly to the knowledge base that would influence future Soviet aviation developments for decades. The SB's service with foreign air forces also demonstrated the aircraft's remarkable adaptability to different climates, maintenance philosophies, and tactical requirements. The technical innovations pioneered in the SB would influence bomber design philosophy worldwide for many decades after its introduction to service. The revolutionary concept of speed as the primary defense mechanism, considered radical when Tupolev first proposed it, gradually became orthodox thinking in air forces throughout the world. Modern strategic bombers, from the American B-52 Stratofortress to the Soviet Tu-95 Bear, trace their fundamental conceptual lineage directly back to the design principles established by the SB development team in those cramped Moscow offices during the transformative mid-1930s. The emphasis on aerodynamic cleanliness, internal weapon storage, and high-speed flight characteristics became standard features of bomber design that persist to this day. Perhaps most importantly for Soviet prestige and international standing, the SB conclusively established the Soviet Union as a genuine major power in military aviation technology. The flying machine's outstanding success in combat, combined with its profound influence on international aviation development, demonstrated beyond question that Soviet engineers could not only match the best Western technical achievements, but could pioneer revolutionary innovations that set entirely new global standards. This technological credibility would prove absolutely crucial during the Cold War period, when aviation capabilities became powerful symbols of national strength and ideological superiority. The SB's legacy lived on in successive generations of Soviet bombers that continued to challenge Western air defenses and demonstrate Soviet technological prowess on the world stage. Today, surviving examples of the Tupolev SB rest quietly in aviation museums around the world, their polished aluminum surfaces reflecting display hall lighting rather than the deadly muzzle flashes of enemy fighters. Visitors who examine these historic flying machines closely can still discern the elegant engineering solutions that made them so formidable, from the clean aerodynamic lines that provided their legendary speed to the robust structural details that enabled survival under the most extreme combat conditions imaginable. These preserved aircraft serve as tangible reminders of an era when individual bomber designs could influence the course of global conflicts, and when engineering excellence provided crucial advantages on battlefields that ultimately determined the fate of entire nations.